Hello, everyone. Good morning, good evening, good afternoon, depending on where you're located today. Welcome to our blockchain workshop, Deploy a Blockchain App for Payload Management in Satellite Manufacturing. So before we get started and jump in, I'm going to go over just a few pieces of housekeeping for us here. So if you scroll to the top of the chat, you will see links to all of the resources you will need in order to follow along. Or if you would like to reference anything that we cover today later, the links are in the chat as well as in the slides. I have the link to the slides there as well, so you'll have access to everything that's included within the slides. So to answer your question, yes, the session today is being recorded. You will be able to access the replay by joining the link, the same URL that you joined with today. The live stream recording will automatically convert into a replay for you. So you'll be able to join with the same link and watch the replay. So this is the GitHub repo that we're going to use today. So this is also posted at the top of the chat, so you can go ahead and just copy and paste or just click on it to get access to the GitHub repo. So one of the things that I've started to do is I want all of you to be aware that we have a lot of free learning material for you. So through a platform called Acclaim, we have provided for all of our IBM technologies, as well as other technologies. We have free e-learning resources for you. You can earn badges. They give you a nice foundation to learning different technologies. So for this workshop, I've paired our Blockchain Essentials badge. These are pathways or journeys, so to speak. So you'll actually do a few different modules that you'll earn a badge for each one completing. And once you've completed all of the modules, you'll earn the main badge, the IBM Blockchain Platform Essentials badge. I highly, highly encourage it. I've earned this badge. I thought it was really useful. We also have data science, cloud native development, building with Python or R, cloud infrastructure, all kinds of things. So I personally enjoy the learning journey and earning the badges, and I highly recommend. There's also the IBM Blockchain Platform Developer Badge. This is another badge we have as well that's a little more hands-on, introduces you to the VSCode extension and how to build your first smart contract. So I highly recommend this one as well. And again, this is all included in the slides that you have access to today. So if you haven't already, you will need an IBM Cloud account in order to build with IBM Blockchain or any of our service offerings. What's nice is that we have a free light tier account for you. So this link is in the chat as well at the top. So what you'll do is you'll create an IBM Cloud free light tier account. And it's completely free to use. So we have over 40 light plan services, machine learning, blockchain, code engine, Kubernetes, OpenShift. We have access to all of our services through your IBM Cloud portal. And we have over 40 light tiers, which we're always adding new services as well. You can also access, if you click the button at the bottom of the screen to check in, that will take you to either log in or create your IBM Cloud account as well. So if you haven't already, feel free to share in the chat a little bit about you, your name and pronouns, your title, what company you work for, maybe what program you're currently studying in, where you're joining from, something you love, and then a quirk, something that's uniquely weird or different about you. So I'll go first as an example. I'll start us off. So my name is Jenna. My pronouns are she, her. I'm a cloud developer advocate for IBM. I'm from Detroit. I'm currently joining from Detroit, although technically I work in Austin. My team members were in New York, and now we're just kind of everywhere. So something I love are my dogs. I have Yorkies, and they're like tiny babies that never, ever grow up. And then a quirk, so something that's uniquely weird or different about me. I have an obsession with tuna melts or tuna salad sandwiches. It's kind of my go-to. And if I order it at a restaurant and they do a really bad job with it, I judge everything else on the menu based off of it. So that's a little bit about me. So feel free to share in the chat so we can get to know you all a little better. A tuna melt does sound really good right now, actually. So if you'd like to connect with me, you can connect with me at jwritten on all social platforms across the board. I think I'm on about just every platform now, working on updating stuff. I would like to pass things over to my teammate here, Soumya. Soumya and let her introduce herself, tell you a little bit about her, and then she's going to take you on a blockchain journey this morning. So go ahead, Soumya.
Thank you, Jenna. Hello, everybody. Thanks for joining today. My name is Soumya Janakiraman, and I am a senior software engineer at IBM. I have been working on blockchain for the last three years, and I love it. I love developing POCs or applications on this blockchain platform, making smart contracts fun. How much fun can I introduce into the smart contracts? That's my thinking when I do this work. Other than this, as hobbies, I would say I love to listen to music, lose myself, and dance to the music and lose myself. That's the best state I can be in. Other than that, I would like to be on a motorbike. I mean, the new bikes are too heavy. Sometimes they scare me, but I'd still love to be on a bike and go high speed on that. So that said, I would like to start this workshop. So let me share my screen and with my presentation. I hope you all can see my screen. The slide says deploy a blockchain app for payload management in satellite manufacturing.
Yep, we can see it.
Thanks, Jenna. All right, this is what we are going to talk about today. We'll go through an extremely quick run through through the basics of blockchain. Again, a very quick introduction to Nano Satellites. I'll walk you through IBM Blockchain extension in VS Code as I set up my application to do the demo. I say here stand up a Hyperledger Fabric network, but I already have it up and running so as to save time. Sometimes it takes quite some time. I didn't want you all to wait and having an awkward pause there. And finally, we'll go through the Fabric client, that is the API server, and an Angular web application to go through a space check use case. Okay, what is blockchain? Basically, the underlying technology is, in my opinion, this one. The picture depicts this quite simply. Please note this URL here. They have this website has a video, and then you can play with it and then see how it changes as well. So a blockchain is a sequence of blocks of data chained by hashes. I repeat, blockchain is a chain of blocks of data, okay, secured cryptographically and chained using hashes. So let us say this is one block of data. There are two hash values in this block of data. This first hash value is the hash value of the previous block. The second hash value is the hash value of this block. And as you can see, the previous block's hash value is placed here, and this current block's hash value is placed in the next block. So if I go and change, and let us say this is the rightmost block is the latest block that has been added. If that is the last block, if I try to go back and change this block, that is the leftmost block in the display, then the hash value changes. So this then won't match with this hash value, and the chain will be broken. So that is how it is kept intact. So any modification done at a later point of time breaks the chain, and you know someone has tampered with it. That is the short explanation of what the underlying blockchain technology is. Again, I would suggest you all to look at this website. It gives a very nice, simple illustration. So what is the problem that we are trying to solve? So before all these computers came in, there were only paper books. So let us say there was a bank account or an insurance account to be maintained. How was that maintained? They were maintained in books called ledgers. Ledgers are books used in accounts to maintain assets. So if participant A is a customer like you and me who wants to take an insurance account, and there is another participant B, there is other party called the insurance provider, the other party called a bank because of bank transactions, and other regulatory bodies like someone overseeing if the public's interests are safeguarded, and an insurance company's auditor himself. So now there are so many parties involved in creating an insurance account and maintaining the insurance account. So how did they do it? So now you see each of them had a book and they wrote down what their view of that account is. If something had to be changed, let us say participant A wanted to change something in the account, upgrade it, then he would talk to the insurance provider. These two parties talk, the others are out of the picture. Even if something changes here between these two books, the other books are still out of sync. That is what is depicted by the different colors here. So even after computers came in, it was still the same. Imagine a database in each one of these premises instead of a book. Each one had their own database. They would change data in their own database, communicate with other parties, change their own database or a partial set of database. The problem still remained that all the books are not in sync and each one of them had different view of the common account that they are trying to manage, and even doing that was so inefficient because of the communication overhead and the time delays. So inefficient and quite vulnerable as well, right? I can, as a participant, as a consumer here, I could write anything here and I would say that is what you told me. There is no one to say, no one to verify who told what, who did what. So how are all these problems solved? So blockchain, does that solve all these problems? Let us see. So what blockchain does is it brings in a distributed ledger. Again, going back, the ledger terms comes from the book that was called a ledger earlier. So now we have a distributed ledger, which is shared in the sense it is replicated with all these parties. And when a change has to be made in one of these copies, a person proposes a change. Let us say, again, participant A proposes to upgrade the account. The participant A proposes a change. It is then the proposal is sent to all the parties. They all would consent and then give their input on that. If at all something has to be changed, and finally a consensus has to be arrived. And once a consensus is arrived, then they agree to that change or the transaction. Then all of them, note, all of them commit the same data to their own copy of the ledger. So now, because it is all over a same network, it all happens efficiently. A message from participant A can go to all the other participants. Each person can see the transaction that is happening. So transparency is is available, and once they all give their consensus and the data is saved, all of them have the same copy of data. So that is achieved. Now, given that all this is saved under using blockchain technology, going back to our previous picture of uh, the blockchain, once it is written, it cannot be changed. So therein it brings immutability and finality. So once immutability is in there, you first write A and then A2, A1, A2, A3, they are all there. It cannot be erased. So provenance is there. So let us say participant A created an account to begin with, then the account was changed to change 1, that is written to the blockchain, then change 2, that is written to the blockchain with time, date stamp and time, and who changed it. So going back, one can always get the provenance of this account starting from the beginning to this point. So that is what the distributed ledger technology brings us. Oh, I guess I covered all these things already. So let us recap. So it brings in a trusted distributed ledger with shared business processes, because all these are over a network and digital network. Business processes are connected now, and efficiency is built in already. We saw how consensus and provenance and immutability and finality are brought in. All this increases the trust and transparency. So more players come into this business process, so that each person's interests uh, are are ensured, and each one of them have equal participation in the network. So Bitcoin was the first solution that leveraged the blockchain technology. Ethereum, Hyperledger Fabric, Core, R3, Corda, or they all are um, other solutions that leveraged blockchain technology. So coming to Hyperledger Fabric is an open source uh, platform from Linux Foundation with major contribution from IBM, and this is a de facto solution for enterprise grade blockchain solutions. Excuse me for a second. So with the Hyperledger Fabric being an open source platform, IBM blockchain platform is built on top of Hyperledger Fabric, and this uh, tooling makes it easy to develop solutions for various industry use cases like banking and financial markets, insurance, retail, supply chain, healthcare, automotive, and space tech. So you can refer to more of these discussions in these URLs given at the bottom of the slide. So today, what we are going to discuss is one of the use cases in space tech industry. So let us go space bound. So what is this? This is a news clipping from February 2017 from spacenews.com. So it says India sets record with launch of 104 satellites on a single rocket. So what is special about this? It is the astounding number of satellites on a single launch. And all these 104 satellites were successfully launched into their orbits. So again, what is special about 104 satellites here? Out of these 104 satellites, 3 of the satellites were the regular satellites. What I mean by that is, excuse me, regular huge satellites. The rest of them were nano satellites. What do I mean by nano satellites? Nano satellites, as the name suggests, they are actually, excuse me, they are actually 10 centimeters by 10 centimeters by 10 centimeters size, literally like a Rubik's Cube. You can hold it in the palm of your hand. Isn't it amazing? This is a satellite by itself. You can hold it in your hand, and once it gets launched and it is in orbit, it collects data and sends data down to Earth. Oh, that is amazing. And what are the units of this nano satellite? It's called 1U, and when there are 2 blocks of this, 2U, 3U, and so on. So one can build these nano satellites in these units so that they can be held in launchers and then released in orbit in space. So that is the context in which we are discussing our use case. So why discuss these nano satellites? These nano satellites, to begin with, they were started for some students in some university. At that time, when it was suggested, uh, people wondered whether it makes sense, whether it is viable, technologically viable or not. But today, so many hundreds of these, or maybe more, thousands of these satellites have been launched into space, and they are already functioning. So given that today this has become a very, very valuable tool for research, for commercial, and for students as well to try their hand in building their own satellite. So look at the cost comparison here. So to build a nano satellite, it would take €250,000 versus 500 euros versus 500 million euros for a regular satellite. And the development time, this, in my opinion, is the biggest game changer, because to design and develop a nano satellite, it would take about 8 months, let us say. To build a regular satellite, anywhere from 5 to 15 years. In this 5 to 15 years, in today's date and age, technology changes so fast that by the time the satellite is built, it is already obsolete. It could be already obsolete. The markets could change, the needs, society needs could change. So by the time it is built or it is in orbit, it is no longer market appropriate. At the same time, a nano satellite, things could change here as well. A 1-year period time, things could change. But because of the cost, they could be replaced more regularly. Because of the because of the cost, it could be that the companies need not think too much to replace an existing nano satellite in a constellation of satellites. It could be upgraded uh, quite much easier than upgrading a regular satellite. So with that said, when there are a lot of companies, startups, and students developing the satellites, there are launchers, I would say micro launchers, who have come up to provide launching service to the satellite owners or payload owners. So the context that we are discussing for this use case is this. There are 3 actors. One, a payload owner who wants to design and develop and operate a satellite or a nano satellite. I would say a student in a university who wants to build and launch it using a launcher and then work on the data that comes from this satellite. The second actor is a satellite launcher who provides this launching service to different satellites. And because space is a shared resource to all the nations, all mankind, there are regulatory authorities like Federal Aviation Administration or FCC, Federal Communications Commission. They all come in so that they can enforce certain regulations to protect the public, our property, our national interests, our national security, and so on. So another persona is a regulator. So today we will take 3 personas and then go through this use case and see how these 3 parties exchange data on about the payload and take the payload through a sequence of operations. So in this case, the asset that we are tracking using the distributed ledger is payload itself. Physically, a payload owner would design and build a, satellite, ship it to the launcher, and the launcher then launches it into space. Digitally, it is represented as an asset and stored in the ledger. And what we are going to see is how it goes through. What we are going to see is the life cycle of this asset. So initially, a payload owner wants to, let us say Alice is a student in a university, right? So she wants to build a satellite, a nano satellite. So she requests a slot with a launcher. Let us say an Acme launcher is a company who provides launching service. So Alice wants to book my flight. Then launcher would say, okay, I see the details of your payload. I can assign a slot for you in this launcher, and the payload, then the state of the payload gets changed from slot assigned. And then once a slot is assigned, Alice then goes, designs and develops the payload, and then ships the payload to the launcher and marks it on the asset saying the payload has been shipped. Once the payload is received by the launcher, he can then update the asset that the payload has been received. And after he does all his verifications, all his certifications based on the rules and regulations from the regulatory authority, he says he clears it for flight. I mean, this is an extremely, extremely simplified view of the interactions between these parties. There are more parties, there are more documentations involved, there are much, much more technical specifications exchanged. But we are not here to discuss the payload details and what goes on between these 3 in too much of detail. What we are here is to focus on how we can represent this in Hyperledger Fabric and take the asset through these states and hence monitor the interactions between these parties. Gain the regulatory authority, he has visibility into the entire process. I would say read-only visibility. He doesn't have any write access, but he has read access, so that he oversees what happens in these processes. So that said, let us see what application components we are going to see. To begin with, we have Hyperledger Fabric, which is the open source platform that we start with. IBM Blockchain platform is built on top of it. This layer, the middle layer, is the client, is called server in the GitHub repository that is referred here. That acts as a Fabric client, uses Fabric SDK to talk to Hyperledger Fabric on one side. On the other side, it exposes HTTP endpoints. It exposes APIs so that a web application or another application can invoke these APIs and hence submit their transactions to Hyperledger Fabric through this API server. We will see them in action. Then the top layer is a web browser. Here we have an Angular application which we would use to illustrate the exchanges that we just discussed in the previous slide. I will come back and refer to this slide once again as I go through the application. So let us dive in to our code. So what I have here is VS Code. I have the blockchain extension installed, up and running. I also have a Fabric network running. I have it up and running already because it takes time. Sometimes it takes too much time for it to come up. So now I have it up and running. I have one org, that is org1 in this network. I also have a smart contract installed and instantiated on this network. So that is this smart contract. If it was not installed, you would do, let us say I just brought up a network. I just want to go through the steps, what one would do to install and instantiate the smart contracts. Shift Command P would bring up this menu, and I would say package open project that would create a package of the smart contract. I would then install the smart contract, which installs it on a peer, org1 peer in this case. Once installed, if it is the first smart contract installed, I could then instantiate. If I am upgrading a smart contract, I would choose upgrade smart contract option, and then I would choose the smart contract version to be upgraded, and the next one that to be upgraded to, and then take it from there. So once the smart contract is installed, we have the network up and running and the smart contract up and running. Next thing one would do is to share the connection profile of this network with the application. A connection profile is what gives all detail about a network to the application. An application needs the URL, port number, how many peers, how many orgs are there, so on and so forth, all that to connect to a network. That is given by a connection profile. Okay, if I have the connection profile, can I connect? No, you need the certificates, proper certificates to connect to a network. By default, when I start this network, VS Code creates a user, admin user, and also creates the credentials for these users. So I have a wallet with one user, admin user, that is generated. So I have to use this admin user, the credentials from this wallet to connect to that network from an application. So what I would do to export the wallet is right click on this, select export wallet. So and export the wallet to a folder where the application can read from. In this application, it is the application in the that we are referring to is configured to read it from a folder called gateway and local, and this local gen_local_wallet folder. So this is where the wallet is stored. I have already done it, so I am not doing it once again. Once that is done, let me start the server once again. By server, I mean the API server. So I have cloned the repo into this folder. Fabric contract attribute-based access control. And from that folder, I go into application and server folder. Here I have the server code. I run the server. Okay, what we see from here is each line has a each line tells us certain information about how this application has connected to the network that we just uh, verified in VS Code. It is reading from a config file. The config file says connect to a local network, and the wallet is stored in this folder. The admin username is admin, and the password is this. And the organization is member service provider is org1 MSP, and the admin is this org's admin. And using all this, it has connected to the Fabric gateway. When I say Fabric gateway, it is the gateway object in the Fabric SDK. Using this, it has connected to the channel called my channel, which is again specified in the config file. Connecting to the smart contract called Gen Supply Chain Net. The name comes from a smart contract which was developed for a supply chain network. So I'm reusing the name and most of the code here. So it says it's connected to this one, and it also connects to the event. This is out of scope for today's discussion. And on the other side, all this was to connect to the network, and now it is listening on port 300 for 3000 to for any incoming calls to submit any transactions to this network. That said, let us move to the web browser, and here I have the Angular application. So now let us move to the Angular application. So this is the first screen that it would come up. So let me log in as admin. And what do we see here? I already have registered 2 users. The first 3 users are all generated by default by VS Code. The last 2 users are application-specific users that I registered for this workshop. Let me walk you through the registration process once. I want to register a third user, a regulatory authority, FAA or FCC, Communications Commission, Federal Communications Commission. And this is what we are interested in. So when I register a user, what I am doing is I'm registering a user with the Fabric Certificate Authority, Fabric CA. And regularly, I would just give a username and password. But here in this application, I'm adding an attribute called user type. So here, this being a regulator, I'm selecting a regulator. I create a user. User registered successfully. Now I go here. I see that FCC has been registered, but not enrolled. We'll come to this enrollment part later. So what we are doing is we are adding an attribute to a user at the time of registration, and we retrieve this user type, this attribute in the smart contract. Let me go to that picture once again. So initially, when we register from the web browser, we give username and password and an attribute, and that gets registered in Fabric CA. And once that is registered, second step, when we enroll, these credentials get downloaded to a wallet in the file system of the application. That is, in this case, to my local file system. So a wallet gets created. To the wallet, the credentials, all the users' credentials are downloaded to this wallet when I enroll. So once that is done, when a transaction is submitted from the web browser, the certificate is retrieved from the wallet, submitted along with the transaction to the Hyperledger Fabric platform, and this chain code here retrieves the username I'm sorry, the user type attribute from the certificate. That is what we are trying to focus in today's discussion. So let me go back to the application. So now we have the three personas in our discussion registered. This one user needs to be enrolled. Let me enroll first before I continue. FCC, the password I had given was PWD, and now I need to give the same set of details so that it can verify that this was the user registered. By the way, the enrollment has to be done by the user himself who was registered. So once registration is done, the username and password is given to the user and he gets enrolled so that he has the certificate for his user identity. But in our case, we have it all in the API server file system. Now enrollment is successful. With that, we have the certificates of all these users in the file system of the API server. So now let me start the process here. Now Alice, who wants to design and develop a satellite, she comes in and she wants to request a slot. So I say, she comes in and says, book my flight. So she gives a name called, let's say, Payload 1. What is the frequency that will be used for this, used by this payload for communication to Earth? Let's say 2 gigahertz. She says, okay, my payload is going to be a 2 unit, and the mass is going to be 2 kg. Again, once again, this is an extremely simplistic view of the details that a payload owner would give to the launcher or something. So we are trying to capture minimal information here so that we can focus on how it is being done, how it can be done using Hyperledger Fabric, and how the attributes, the user type attribute, can be used for access control. Now this request is submitted. So this has been added to the list. This is the one that was created just now. Note that all these details are the one that was given. Owner is Alice and launcher is not yet assigned. No launcher has accepted this payload yet, so it is not assigned yet. The state of the asset is asset created. So we will take it to these stages. That was the name of the launcher. He comes in and he sees, okay, I see one payload and I can accept this request. So I accept this request and assign a slot. So the launcher is, so what happens is the second transaction is submitted and the asset, which is this one, got changed with launcher name added and the status changed to slot assigned and asset details verified. Whatever details were given by Alice was verified and he assigned a slot. So to see this in the API server, you can see as you submit, you can see the transactions, the details for debugging purposes. So to go back to the, now that the slot has been assigned, Alice now goes and designs and develops this satellite, and the nano satellite is now ready. Now she can ship the payload. Now you can see that this transaction is being submitted by Alice to Fabric Gateway, and this transaction was submitted successfully. So a block was created. Now the asset has changed state, and now when I query all the assets, I still have only one asset, but the state has changed. Now that has been shipped and it has been shipped to the launcher has to receive it. I want to highlight one thing before I go to the next screen. Since we have registered and enrolled, the certificates are available, the user credentials are available with the API server. What is the login screen here is it does not check the password that is entered here. This is given here to note that the access to this application needs to be controlled, and this authorization has to be done outside the purview of this workshop, and hence this login screen, it only uses the username and not the password at all. You could try in anything and it would still log in because it doesn't check the password at all. Now it has been shipped, and in that time that we were talking, the shipment has been received by the launcher, and he says he acknowledges that he has received it. So that again goes back to into the blockchain asset received. Then he verifies the details and he says approve for launch. Then the asset is now cleared for flight. All the stages, it has gone through all the state. So that is how these two parties interact with each other, and all these transactions between these two parties have gone into the blockchain. So how can we see that? That is why we have a regulatory authority, FCC, Federal Communications Commission. As mentioned earlier, he is a regulatory authority. He wants to protect the interests of all parties concerned. So he can see the order history. So what does this say? Alice created a payload called, excuse me, payload 1. It was created at this time. I am in India, so I have given IST. These are all just the timestamp is created, and it's up to us how to display it in whichever time zone we want to display in. So what we see here is the history from the time Alice created this asset. It went to into the hands of the digital asset was then changed by the launcher. He said, okay, I verify this data and I accept. I allot a slot for Alice in this launch at this time. Then now next step, Alice then notices that, okay, I got a slot. Now I can go and design and develop this satellite. Then she ships the asset. That is again noted. Asset received by the launcher, again noted. At any point of time, a launcher cannot come back and say, oh, I did not receive this asset. Oh, I received this asset late, so I could not send it in this launch. Because these transactions are submitted along with these user credentials, the non-repudiation is available. So he cannot come back and say, I didn't do it. His signature his digital signature in the transaction, which is stored in the blockchain, says you did it at this time and this was the change that you made. So this history gives us a record where any audit is needed. This is available. Provenance at any point of time, it is available. For quality control, for example, which is it's not covered here, there could be some documentation which says this was verified, and a document could be added. Insurance companies would want to see the quality control documents stored in blockchain, so that if some problem happens, they can go back and verify, okay, what did you do to ensure that they did not crash, this did not fail, right? So for all these purposes, these details are available to go back and audit. So let us quickly jump into the code and see how these attributes are used. They are used in 2 points. So as I told you initially, it is used at the time of registration where it is entered. I hope you can see what I am highlighting here. This is a code in application server utils.js in the code repository that was shared, that is shared with you. Along with the username and password, I also add an attribute called user type and a value for that attribute, which is, in our case, it says a payload owner, a regulator, or a launcher. Those are the user types. Next, when the user logs in, a, a different portal comes up, right? When a regulator logs in, a regulator portal comes up, and then when he clicks on an asset, the history comes up. This is done using, again, this same attribute. This doesn't hit the Hyperledger Fabric, smart contract at all. It goes to the Fabric CA. Let me go back to this one, this picture again. At that time, it goes to Fabric CA and gets the user and the user type and shows a different portal for different users as per their user type. Third, when a user submits a transaction, let's say let me quickly log out of here and then go to a launching page, launchers portal. So if there were multiple launchers, this launcher would see, the Acme launcher should see only those payloads that he is dealing with, and not the other payloads. The same way, if Alice has logged in, she should see only the payloads that she is the owner of, and not John's payload and Greg's payload, right? So that is also done using the user type attribute, and that is done using access control in the smart contract. Let me quickly show you the code where that is being done. So this is a function in the smart contract. So when query all assets is submitted by a user, let us say Alice, it goes through this filtration based on the user type. It goes through this filtration. So where does this get the user type from? It gets the user type from this function, and that is where this attribute called user type is used, and access control is implemented using this attribute. This get current user type is a function here. And it gets the attribute value. The attribute name is user type, and it gets the attribute value from the client's identity that is submitted along with the transaction that is available in this context. So the Fabric SDK calls get this attribute value from the certificate, user certificate, or the user client's identity, and gets us the user type. This, again, remember, this was the user type that we entered at the time of registration, and using that we are doing the access control. The same is the case when you query for history. Only regulators can see the history, and not a launcher or a payload owner. A customer here, it's not used currently. So in this case, just focus on regulator. So that is how the attribute-based access control is implemented in the smart contract, or whether going to the certificate authority and using it at the API level as well. So that said, that brings to the end of this presentation. If you have any questions, I'll be happy to answer them. Let me quickly check the chat window. Let me stop sharing. Jenna, if you can take over, it's yours.
Yes. Yes. Thank you so much, Soumya. So feel free to put any questions in the chat. I did want to share a few things before we go. So first of all, thank you all so much for coming, and congrats to all of you for making it through to the end, learning a bit about blockchain, how to deploy a blockchain application. So I have here for all of you, I have all of the resources that we've gone over today, the slides and everything. One thing I would like to share, if you all would be so kind, if I can get back to, oops, here, is a very quick 2-question feedback survey. We very much appreciate your feedback. We're always looking to improve and include anything. With these slides, you do have comment access, so you can comment on anything that's not clear, leave us any little notes or messages. If you would like to connect with either of us, let me just add that as well. If you would like to connect with either of us, I've just posted our LinkedIn as well. So at the end of the slides here, I also have all the event resources, some blockchain resources, as well as in the slides, we have Soumya's as well, and our blockchain certifications. So again, like I said, thank you so much for coming. If you have any questions, feel free to throw those in the chat. There's also a question section at the bottom that you can add questions to. We have a few minutes. We can answer any questions that you have. And if you enjoyed our content today and you would like to attend more workshops or view any of our previous content, feel free to register for any of our events on Meetup and follow our social, Twitter, Twitch, YouTube. You can follow us all there. So thank you all so much for coming. I'm going to give you a few minutes to get any of the resources or anything that you might want to get before we go here. I'm going to watch just for one more minute for any questions you might have. Okay, well, thank you all so much for coming, and feel free to reach out to us with any further questions you have, or any help you might need with anything. All right, we'll see you next time.
Thank you, Jenna. See you all next time.
Thank you so much, Soumya.
Bye.